There are more courses topically over a huge number of areas, but with a small number of students get together with a faculty member for 3 months or whatever, and they talk about that, and the faculty member brings these young people to his home or her home for dinner and whatever. So it's a way of adding enrichment and these more difficult things to achieve in a narrow course, lecture course setting. So we've created seminar courses and things like that with small groups and a faculty member who stay with it, and then they get to know each other and they understand, and then in another quarter a student may go do it over here. Okay, but it has the characteristic that it's intimate, so it's friendly. And the faculty member is not the boss, whatever, telling everybody what they should do. His or her job is to make the process work. And also, we all realize, we begin to learn from the students. Okay, we learn because they go read something we didn't know, or they bring a youthful perspective, and we're older, and so we don't, have that same connection. So there's a kind of way of bridging the generations. And we don't tell them that we're learning from them, but it's true. They know.
I kind of get your point, and I agree with you completely. I think we don't teach students now. We lead them and we discover them.
I agree with Mac. We probably have a smaller set of, we call those discovery courses, and we don't get quite the credit that you get. So it's sort of voluntary on the professor to take that on top of the regular teaching load. Complementary to that would be coming up with majors that come and go, like astrobiology, like energy, like nanotechnology, and these traditionally have not been majors in undergraduate for undergraduates. And so we've tried several of those out. Some of them are very successful and they grow. And some of them maybe won't grow so well, but those students that get through that curriculum with a degree definitely are very attractive to the job market and to graduate schools, but more importantly, they've given themselves a broad foundation for their own research and development.
I mean, actual experimental or in science, physics, they would be an experimental or theoretical problem that they work on. And they work on in a research group. But it's a course, or at least they get credit for it. And there are requirements, okay? You have to define a problem, you have to work on it, you have to write it up. So when you're done, you give both a written report of what you did and an oral presentation about it. So it goes from conception through doing it to the final communication part, both written and oral. And that is an eye-opener for most students. They don't see it with that continuum of what you must do, and they improve their writing skills and communication skills. But the main thing is that they see that this is the whole process. It's not just one piece of it.
We've developed the senior thesis course at the University of Illinois that's been going on for 13 years now. And I taught it the last 2 years. And what we do is the spring semester of the junior, typically, it could be anyone, but it's limited in size because it's takes so much time for the teachers. It's called Introduction to Physics Research. And it's a writing course. It's a quantitative writing course, and they write abstracts and figure captions, effective figures, graphing. We give lectures on science ethics, publishing, collaboration, etc. And they give journal clubs, and they have to do a lot of writing and presenting Then they're each placed in research over the summer. And they come back in the fall and they write their senior thesis with a lot of back and forth input and section on how to write it. They give a poster, and we have a special poster session. And then they give a 12-minute talk, which is based on the kind of talks that we give in our annual meetings. And these students have been highly successful. Just the number of prestigious fellowships and tracking them 2 years later. And other universities are copying this, and we're sharing this information freely. But I think we've been working on this beta-tested model now for 13 years, and I think it's very helpful for the students.
I think that it's going to take us a while to learn how to do all of this from the instructional point of view. So I think we have to, again, be patient and not try to discover them all at the beginning. Get a list, be critical about it, try it out, pour water on the things that grow and not on the others. Then periodically ask the question, well, this is fine, but what else do we need? We just can't see that far ahead.
Sure.
Okay, and then you may come to this, I won't bring it up quite, I won't elaborate, but there is a resource issue here. I mean, where are the resources going to be found to do all of this? Okay, and that's not easy. But the main point I want to make now is, it's like Laura and I were saying today, take a few steps, look around, oh, this is the way we want to go.
Right.
And going this way or that way may be institutionally dependent.
Right.
Right. So, and it also makes it really fun.